Now I want to move on to the more interesting area of where we have probabilities of two events occurring at the same time. Here's an extension of the previous example where we have 347 uni students and we've asked them to self-rate their level of happiness: very happy, pretty happy, not so happy, 95, very happy, 188, pretty happy, etc. And this time we've cross-tabulated the happiness variable against the stress variable, self-reported level of stress, and that's been categorized as no stress, some stress, or stressed out. Because both these variables are categorical in nature, when we can describe the relationship between them using a contingency table. In this particular contingency table, the first cell here tells us that 66 of the students, of the 347 students, are both very happy and report no stress. We've been talking about using percentages as a method of converting percentages into probabilities. The 66 students who are both very happy and have no stress represent 19% of the 347 students in the sample. And so the probability, if we took one student at random, the probability that that one student fell into the category which was both very happy and no stress is 19%. The probability of selecting someone at random who's both very happy and reports no stress is 19%. This probability of two events occurring at the same time is called a joint probability. The joint probability of being very happy and having some stress is 8.1%, etc. All of these percentages add up to 100% across the whole table. That's one type of probability. There's actually a different type of probability which may be used more often. It's called a conditional probability. In the conditional probabilities, we're looking at the row percentages or the column percentages. By a row percentage, I mean that the percentages add up to 100 in each row of the table. That means the very happy people is 100% of everyone that we're looking at, and amongst the very happy people, 69.5% of them have no stress, 29.5% have some stress, and only 1.1% are stressed out. So if I was to choose one person at random amongst those who are very happy, okay, so I'm just limiting my selection down to very happy people. If I was to choose one person at random, I have 1.1% chance that that person will be stressed out. So the probability of getting a stressed out, selecting a stressed out student, if given that I'm only looking in the very happy group, so this vertical bar here means given that we're restricting our attention to this subgroup, the probability of getting a stressed out person, given that we're looking for at the very happy people, is 1.1%. Conditional probabilities work in the other direction as well. They work on the column percentages. So in this table, the percentages add up to 100% down each column. So of all of the no stressed people, 45.2% of them are very happy, 45.9% of them pretty happy, and 8.9% are not so happy. So if I was to choose somebody, a student at random from the no stress group, then I have a 45.2% chance that they're a very happy student. So the probability of choosing a very happy student, given that I'm only looking at the those who said they had no stress, is 45.2%. These conditional probabilities are actually very helpful in, or these row and column percentages are actually very helpful in establishing whether relationships exist between two variables, with there is association between two variables. We're going to get into that a lot more in, say, chapter 7, or at week 7 or 8. But one thing which we can look at straight away is whether the two variables are completely independent of each other. If there is no relationship at all between whether a student is happy and whether a student is stressed, then we would expect, if we're looking at the row percentages in this case, we would expect that the same proportion of students would be stressed out in the very happy group, as in the pretty happy group, as in the not so happy group. Okay, so it doesn't matter which happiness group you're in, you still have the same probability of being stressed out. And that probability of being stressed out is the overall, the total percentage for that category. If you have more chance, if you're more likely to be stressed out, if the people in the not so happy group are more likely to be stressed out, have a higher proportion of people who are stressed out than those in the very happy group, then happiness has some impact on stress. Okay, so which happiness group you're in has some impact on your stress level. In this case, happiness has no impact on stress, and so the two variables are completely independent of each other. And there's a formula, an associated formula in the textbook, which encourages you to compare the row percentages against the total percentage, and see if these values differ from each other. It's an indication that there's a relationship between the two variables. The two variables aren't independent. In this case, if we got this pattern happening, then the two variables would be independent of each other. Same applies for column percentages. If the two variables were completely independent of each other, then we would expect to see the same proportion of we would expect the same proportion of people in the no stress group to be very happy as the proportion in the some stress group as a proportion in the stressed out group. We would expect these proportions to be the same in all of the groups if the groups are if the two categorical variables are independent of each other. So in summary, one way to estimate the probability of an event is to observe the past rate of occurrence and to extrapolate those probabilities to the future. Technically, we should be looking at proportions, but we're going to use percentages probably more often in this unit. When it comes to looking at joint probability between two events, but between two possible outcomes, we can work out the joint probability that two events occur together. We can also, when we've got two variables, we can look at the conditional probabilities within a selected subpopulation of one variable, based on one variable. If the conditional probabilities are the same across all subpopulations and the events are independent of each other,